All right, welcome. We are going to be working on our Pythagorean Theorem word problems today. We're going to be doing 5 out of your 15 total, which means you will only have 10 problems to do for your homework. Again, we do go a little bit out of order for some of them. Just do it in the order that we do, and you will be good. All right, so again, we will take the word problem, we will translate it into a math problem, and then we will solve it based off the skill that we have been working on. So we're going to go ahead and do number 1. Read it to yourself as I read it aloud, please. The slide at the playground has a height of, thank you, 6 feet. The base of the slide measured on the ground is 8 feet. What is the length of the sliding board? So again, imagine you're a little kid going on a slide. So here we go. All I want from you again is a right triangle. So go ahead and sketch a right triangle that looks something like this. Doesn't have to be perfect, but again, using your straight edge will make it a little bit easier. We know it's a right triangle again because we put the little corner there. You got your little step ladder. And so on. So you don't have to add those little pieces. But again, every problem that we're going to be constructing is a right triangle. So it says the slide at the playground has a height of 6 feet. Go ahead and put the 6 feet where you think it would go for your slide, your right triangle. You only have 3 places for it. Height should obviously be here. And it says the base, go ahead and put the base, which is an 8, where you think it will be. The base is obviously here. And then the question confirms that we are trying to find side C. It says, what is the length of the sliding board? So again, going down the slide and so on. When I grew up in Santa Cruz, there was this amazing slide. It's the kind that with the bumps as well. And we took wax paper because it was a metal slide. Don't know if you've ever done it before, but wax paper just like makes you go so fast. It's awesome. All right, so what we have here again is, if you notice, 6 and 8 can both be divided by 2. So 6 we know is 2 times 3. 8 is 2 times 4. So C is really 2 times, it's a triple, 3, 4, 5. So we think C is 10. Can C be 10? Because remember, C has to be the greatest number. Is C the greatest number? Yeah. Yes, it is. All right, go ahead and make a quick sentence answer. It wants to know, what is the length of the sliding board? Again, I know it's not English class, but we practice our awesome skills, especially since it's word problems, getting ready for the end of the year test. Just make a simple sentence answer. Should say something like, the length of the sliding board is 10, and you're using your units, 10 feet. Again, simple sentence answer. All right, when you're ready, we're going to go ahead and look at number 2. All right, read it to yourself as I read it aloud on number 2. A 17-foot ladder is leaning against the wall of a building. The height from the ground to the top of the ladder measures 15 feet. How far away is the base of the ladder from the building? So go ahead and sketch a right triangle. So where does the 17 go representing the ladder? Put it where you think. So again, we got 3 parts of our triangle, 3 parts of our scenario here. We've got the wall, the ladder, and they call it the base again, which is really just the ground. So hopefully you put the 17 here. You're leaning the ladder against the wall. It says the height from the ground to the top of the ladder measures 15 feet. So this is the height. Got our 15. And our goal is to find the base, which this is C. Most students say this is A, so this would be B. So, do you know what it is? Is it a triple? Yes, it's a triple. So even though A is usually the smaller number, we did say that again, A and B can be switched, if you will. So what is the missing side? Not 6, 8. Your triple is 8, 15, 17. So again, if it's a triple, you really don't have any work to do if you remember the triple. So make a quick sentence answer. How far away is the base of the ladder from the building? Again, nice, simple answer, please. You're answering the question, though, using the words given to you, using the value that we just found, and of course, using the correct units. All right, we are on number 3 now. So this one gets a little bit more in depth. It's not just a straight, okay, what's the answer? It's find an answer and then does it work? Kind of similar to some of the problems on last night's homework. So we're going to go ahead and again sketch a right triangle. But this time it says a 13-foot ladder is placed 5 feet away from the wall. So in other words, it's going to look a little bit more like this, where the bottom piece, it already tells us the base. It says it's placed 5 feet away from the wall. So if this is the wall here, the base is the 5 this time. It says the distance from the ground straight up to the top of the wall is 13 feet. So the height is 13. So it's asking really, is the ladder going to work? It says it's a 13-foot ladder. You have 2 ways to do this. The first one I'm going to suggest we do is actually just find out what C is and compare that length with the ladder length. Some students may say, well, C is 13 because it tells me the ladder's 13. But if you do that, it's more of a problem from yesterday in checking, is it a right triangle? Would it fit? But I want to practice it this way. So I know that this cannot be 12. Even though the triple 5, 12, 13 sounds good, why can C not be 12? C has to be the greatest number. So we're going to say it's not 12. So we will show our Pythagorean theorem. So we're going to plug in our numbers. You can say A is 13 or A is 5. It really doesn't matter because you have to square and add them together anyways. All right, if you add them together, What do you get? 180, 84, 94. Because that's almost 170. 170 plus 20 is 190. 194. Square root both sides, please. And we're just going to go straight to the approximate answer. So which means we're going to go ahead and practice our number line skill again. My original is the square root of 194. But you know what? I don't have to do the whole thing because I know the bigger one is going to be the square root of 196, which is really a 14. So the square root of 194 is so close to that. So what should that be? 8 or 9, we'll take it. So about 13.8 or maybe 13.9. We really don't know right now, but we don't need to know the exact because if I know that my C is, let's just say the smaller one for right now, 13.8, it's asking, will the ladder fit to that top of the wall? So if you can, get out your highlighter. So if the full distance using the height of 13 and the base of the 5, I found that C is 13.8. My ladder says it's only 13 feet though. So would the ladder reach that top that it is expecting to reach? No. You got a little bit of distance, almost a foot short. So when you make your highlighter mark, let me zoom in for you. Show how it doesn't go all the way because the ladder is only 13. So the ladder will not fit because the ladder is only 13. It's not asking will it fit inside a box like a previous problem. It's asking is the ladder long enough to reach that top of the wall using the numbers given to you. If it was will it fit inside the box question, then yes, it would work. But since it's trying to lean it up against the wall at the specific points, it would not work. I think you're getting... You would need the ladder to be 13.8, or you could technically have a longer ladder. So it's a little bit backwards from last night's questions, which is why I think you're getting confused. All right. Okay, moving on. 2 more. So make a quick sentence answer again. It's asking, will the ladder fit? There's a different way to do this a little bit. If it's a little bit easier for some of you because you were getting a little confused. Another way to set it up, it's saying is, okay, if you know the ladder is 13 and you know this is 5, will it reach that height up there? So this would be the triple idea. If that's 13, this is 5, this would have to be 12. So it means the highest point that the ladder could go is only 12 feet. So this is a little bit quicker, but the other one is a little bit more in depth with the understanding. So again, this is the ladder. This is the base. This is the wall. So the 13-foot ladder would only reach 12 feet high on the wall when it wants to reach 13 feet. So you can do it that way as well. All right, let's look at number 13. So turn your worksheet over. All right, number 13. The area of a square is 81 square centimeters. So this time we're actually going to go ahead and draw a square. We know, of course, that a square has a right angle. Now, it says the area is 81. Now, using your skills from elementary, what are the two sides going to be then? Now, you remember again, for a square, it's length times width, base times height, or because it's the exact same number, sometimes it's represented as side squared. So what are the two numbers that you would have for your side? You would say a 9 multiplied by a 9. So if we now know the dimensions for the length and width, base times height, or the sides, it says to find the diagonal length. So with your straight edge, we're going to go ahead and work with the diagonal. And the diagonal, again, creates a right triangle, which will allow me to find side C. So we don't know it. It's not a triple, so we're going to go ahead and say a squared plus b squared equals c squared. But on this one, it says leave answer in simplified radical form, which means we're not going to be doing a decimal answer, which means it's a little bit less work. So we plug it in, we work it out. So c squared is equal to 162. Square root both sides. Now again, the simplified radical form, that's really talking about the factor tree problem. So if you can go ahead with me and break up your 162. So since it's even, we can say 2 multiplied by 81. We know 81 is really 9 times 9. So we've got a bunch of 3s. All right, do we have any pairs? We see a pair of 3s. But we see an additional pair of 3s. So maybe we can do it in our head here. If I have a pair of 3s and I have another pair of 3s, we want to figure out, again, what goes outside and what goes inside. Now, inside, remember, is the leftover stuff. The leftover, the loner, like some of you wanted to call it, is just the 2. So that means the 2 is going to go inside. That's the leftover or loner. The outside is the pairs. Now we said we have a pair of 3s and another pair of 3s. So what am I going to put on the outside? Not a 3, because I have 2 pairs of 3s, not a 6. I have a 9. Because remember, it's really a 3 and a 3. Multiplication gives me the 9. And then, of course, based off of our units, we're going to go ahead and let me see if I can squeeze it in centimeters. All right, one more. Number 15, please. Start reading number 15 with me as you're finishing writing this up. Last one together. All right, number 15 says, an isosceles triangle has congruent sides of 20 centimeters. So in other words, I do not have a right triangle this time. Isosceles triangle, again, is a triangle that has two sides that are the same, and it tells you congruent sides, which means those two sides are 20 centimeters. It says the base is 10 centimeters. Find the height of the triangle, leave answers in simplified radical form. So, take your straight edge, please. I'm going to try and sketch it the best that I can. You are going to try and show something like this, where your isosceles triangle has two numbers the same, and it says the base is 10. It wants us to find the height of the triangle. Leave answers in simplified radical form. So what you're supposed to do then is you are supposed to take your pencil which gives you a right triangle, which would allow us to find the height of the overall triangle. So in other words, instead of a 10, what is this number going to be here? The 10 is the full mark. Essentially, I'm cutting it in half. So you're going to put a little 5 here. In other words, you are now looking at this triangle. Sorry, it's a little messy. Don't judge me, Nicole. You're so hurt my feelings there, Nicole. Fine. Hurt my feelings. Go home and cry. All right, so in other words, this is the height. This is a 5. This is a 20. This is really the triangle that I'm looking at now. And if I can find the height, that'll be the height of the overall triangle. So this height is really side A or B. So I'm going to call it A. If I can find A, side A from my Pythagorean theorem, then that's the height of the overall triangle. Now, unfortunately, this is not a triple, so I do need to do some work. Remember, this is side C, because that's on the opposite side of the box. Side A and B are interchangeable, so I'm just calling this A. Maybe you would want to call it B. Are we okay on the setup? So I take my isosceles triangle, I zoom in to only a portion of it. That's really a right triangle, which will help me find the height. So let's go ahead and write a squared plus b squared equals c squared. As we saw in the picture, my c is 20. I said I am trying to solve for a, so my b is 5. So I really have a squared plus 25 is equal to, what's 20 squared again? 400. Very nice. So for this problem, since I'm trying to find a instead of c, I really need to subtract my 25. Not going to add it. So that means a squared is equal to 175. I'm going to take the square root of both sides. Sorry, 375. Thank you. Man, you guys are judging me so much. There we go. Now, again, it would like us to have, it says the simplified radical form, which means we're going to have a number in the front and then a number inside, and our units, again, are centimeters. So what we're going to do, again, is our factor tree. So I'll give you a moment while I go cry in the corner, and you do your factor tree. So break it up, please. It ends in a 5, so it means you should divide by a 5. Or maybe you want to do quarters. So let's try that. Let's try quarters. So if you want to think about quarters, how many quarters do you have for $3.75? 15 quarters. We're looking for our pairs. We have a pair of 5s, no other pairs, so it means the 5 goes outside. And what's going to go inside? The 15. Again, it did not want the decimal answer. It wanted the simplified radical answer. So what you need to do on the majority of the problems is set up a simple triangle. Towards the end problems, you might have a different shape, like a square or an isosceles triangle, and then you need to identify where the right triangle is located. So your goal is to complete the remaining problems. When is your Friday assignment due? Tuesday. All right, go ahead and get started and be awesome.
Awesome, boys. So you gotta be like, be awesome.